This is the hard disk drive. That is the hard disk drive. Now, what is the point about this hard disk drive is you can see that in this hard disk drive, usually what happens is you can see the same concept here. The data, you can observe that is the hard disk drive, and you can see there is a read-write head. You can see there is a read-write head. This is the read-write head. And this is the disk. You see disk rotates actually in this direction, round. And we have a read-write head. The read-write head moves in this direction actually, because it is fixed now. It is fixed with that spindle. We have a spindle. To the spindle it is fixed. And disk will rotate round. Disk will rotate round. Disk will rotate round. It will rotate round. But this will be moving like a viper, left to right. It will be moving like a viper. That means now that read-write head is going to read the data in this way. That means in this way. And it is going to read the data in this way. Now, what is problem in this is, suppose we have data A, B, and it has stored these two and it stopped. In the next, it has stored C, D, E here. And now what happens is, this place, the memory, is not utilized. Now, next time when it comes here to read or write, it sees here that there is some data and it cannot go further to write. Then what it will do is, it will go to the next location. From there, it will go to the next location. And here it starts writing the data. That means this head cannot directly go there and store data. It has to go in an order. When it has to go in an order and it sees that there is several data already available, now this is always left empty. That means you have space in your disk, but you are unable to utilize that space. This problem comes every time when we are using a disk. This problem will not come when we are using a tape, because in a tape data is in order. But in disk, data is not in order. That's the reason the memory is available, but we are not able to use it. You know, in previous days and even now also, you have an option called disk defragmentation. In Windows operating system, you will find disk defragmentation. When we run disk defragmentation, what happens is, all used sectors are moved aside and unused sectors are moved aside. When all the used and unused sectors are moved aside, then again space is allocated, we can start using it. But if it is not moved aside, then obviously it will get a problem. And the problem is the memory available but not utilized. This issue is called as overhead. We call this as overhead. Now, what is the overhead problem? Overhead problem is nothing but unable to allocate memory in an order. And due to that, memory is available, but you cannot utilize it. We need to defragment the disk to store the data properly. So overhead is a problem that comes with memory. Due to the memory problems, overhead issues will come regularly. This is overhead. This is overhead. Now, to overcome this overhead issue, in computer programming, they have a concept called array. Now, what is the purpose of array? What is the nature of array is array can store values in a sequential order. If array can store values in a sequential order, then obviously arrays will reduce overhead. That means the main purpose of array in computer programming is to reduce overhead. Arrays in computer programming are used to reduce overhead. And how arrays can reduce overhead? Array reduces overhead by storing values in sequential order. Arrays reduce overhead. Array reduces overhead by storing values in sequential order. Another point, array reduces complexity by storing many values under one name. Array reduces complexity by storing many values under one name. That means the main purpose of array is to reduce overhead and to reduce complexity. So how array reduces overhead? By storing values in a sequential order. And how array reduces complexity? By storing many values under one name. That is actually the purpose of array. So arrays are used for reducing overhead and arrays are used for reducing the complexity. These are the two important points about arrays. And very important is array can store, as I told you, this is option. Array is a collection. Array is a collection of values. Array can store various types of values. Not only that, array size can be changed dynamically. Because this is another point many people tell about array. When we ask about array, they say that array size cannot be changed dynamically. But technically, array size can be changed dynamically. Your technologies have a problem in that. That is the reason in your technology, array size cannot be changed dynamically. Actually, that point also I will show you here. So first point, we have seen that array can store various types of values. Okay. See here, I am allocating a new array and I am giving the size 2. That means later I will show you how to declare arrays and all, right? Now in values of 0, I am storing 10. Values of 1, I am storing 20. Values of 2, I am storing 30. Values of 3, I am storing 40. Values of 4, I am storing 50. That means array size is allocated to 2, but I am storing 4 values into it, 5 values into it. Now, generally, in few technologies, it throws an error saying that it is out of range. Because in those technologies, array size cannot be changed dynamically. But here you can see when I compile and run this, it is not a problem. It can handle all those values. Even your size is defined to 2 and you can increase that size later dynamically. So whenever people talk about arrays, they say that array size cannot be changed dynamically. We can prove that point also wrong. That is related to their technology. And they cannot implement that and give that